This section is about probability models. So everything that we do in this particular chapter is going to involve what we call Bernoulli trials. And a Bernoulli trial is an experiment that involves two outcomes. And our two outcomes are what we call success and failure. Now we'll do more examples of these type of things so you can see what I mean by success and failure. And we'll actually start immediately with example number 1. So you're rolling a die, trying to get a 6. What is the probability that you get a 6 on the third roll? So what we mean by success in this case is what we're looking for, what we're trying to get. So in this case, we're trying to get a 6. So in this context, we mean that success is getting a 6. Failure would be anything else. So in this case, it is not getting a 6. And then our probability of success, we usually denote with the letter P. And since we're rolling a 6-sided die, we are going to have a probability of success of 1/6. Failure you do by doing 1 minus P, which gives you 1 minus 1/6, or 5/6. So we are using what we call random variables. And in this case, the random variable x is just going to represent the time that you get a 6 on, the first time you get a 6. This is especially important if you're taking the AP test. If you're not, don't confuse yourself too much with the notation, but it is good to know. So we actually write this as probability of x equals 3. So what this means is the probability that the first time you get a 6 is your third attempt. And we find this by saying, okay, our first attempt, we don't get a 6, which is 5 out of 6. Second attempt, we don't get a 6, which is still 5 out of 6. But we want our third attempt to be getting a 6, which happens 1 out of 6 times. So our answer for this one is going to be 25 over 216, or 0.1157. I actually prefer to write these as a decimal in the end because 0.1157 looks like it's about 11%, 12%. That's a little bit more meaningful than that fraction. So we call this type of situation a geometric probability model. A geometric probability model is what you're doing when you are looking for the probability of getting your first success in a series of trials. So it always is going to have something to do with your first success. And we have a few formulas that go along with our geometric probability. The first one is for expected value. By the way, in your book, these formulas are on page 389. There's a nice little box there. So the first thing is our expected value, which is just going to be 1 over p. The second one is our standard deviation, which is going to be the square root of q over p squared. So let's use these formulas. For example number 2, it says, in the situation from example number 1, when do you expect to get your first 6 and with what standard deviation? So we're going to use our expected value formula, which is 1 over p, if you remember, our p is 1/6, our q is 5/6. So you're going to do the formula above 1 over p. You're going to get 1 over 1/6, which actually just ends up being 6. So that means that we expect to get our first sixth on our sixth roll. Now our standard deviation has a formula of q over p squared. So you're just going to substitute in your values, which gives you 5/6 over 1/6 squared. Go ahead and work that out on your calculator and make sure that you end up getting 5.477. So your standard deviation is actually really high in comparison to your expected value. So what that means is that your first six can occur within 5.5 rolls of your expected value, which is your sixth roll. So that means that it's very likely that you'll be anywhere between the first and the sixth roll, or even between the sixth and the 11th roll, you'll get your first six. So a huge standard deviation, but it's a good indicator of the fact that it's not necessarily going to be on your sixth roll. It can be all over the place. If your standard deviation was smaller, that would mean we were more certain that our first six would occur on our sixth roll. So let's try another example that has to do with geometric probability. We know that about 20% of students at Lorena are freshmen. What's the probability that you randomly choose from a list of students and get your first freshman on the 5th try? So let's do this by hand first. And just a side note, our P here, our probability of success, is 20%. In this case, success would be getting a freshman. Our probability of failure would be 80%, or 0.8. So what we're going to do is we are going to try to figure this out by saying, okay, so the first 4 times we're getting somebody who's not a freshman, I'm going to write that as 0.8 times 0.8 times 0.8. But the last time we're getting a freshman, so that would be 0.2. If you want to write this shorter, feel free to write it as 0.8 to the 4th times 0.2. When you work this out, you will end up getting about 0.0819. However, you'll find that if you're looking for somebody on the first time on the 5th try, that's fine. But if you end up looking for like your first freshman on the 20th try or something, this gets kind of tedious. So there's actually a way to do this using a calculator. So on your calculator, you are going to go to your distribution menu, which is the second vars. Once you get to that menu, you're going to scroll all the way down, or you can actually go up to the listing that says Geometric PDF. And you're going to put in Geometric PDF of your probability, your P, which is going to be the 0.2, and the number of trials that you want. I believe if you have some of the calculators on the menu, it says X. So you want this on the 5th trial. So if you can either put it as X or the number of trial that you want. You can just think of it that way. So then when you calculate this one out, you will get the same exact answer. This is a nice short way to do it. It is your decision if you want to do it by hand or using a calculator. Either way is okay. The next type of problem is a little bit similar. It still involves geometric probability, but we want to know what is the probability that we get a freshman within the first 3 tries. What that means is that we get a freshman on the 1st try, on the 2nd try, or on the 3rd try. So there are two ways to do this problem. You can either work this whole thing out by hand or you can do it on the calculator. We're going to do it both ways. So if you do it by hand, you're going to do the probability of getting it on the first try. So getting a freshman on the first try is a 20% chance. So you're just going to write this. I'm going to write this as first try as 0.2. Getting a freshman on the second try means that on your first try, you don't get a freshman, which is 0.8. On the second one, you do, so that's 0.2. Now, on the third try would be the first try you get no freshman, second try you get no freshman, the third try you get a freshman. From there, you would multiply this entire thing out and add it together. You can use your calculator to multiply that out. So when you work this out, you end up getting 0.2 plus 0.16 plus 0.128, which gives you 0.488. Now this is one of those situations where you will be really happy that you have a calculator. So we're going to use, in this case, what's called geometric CDF. It's the same menu under the distribution. However, make sure that you're using CDF. So the CDF comes in when you're doing within a certain number of trials. For example, number 3, we wanted to get a freshman on exactly the 5th try. In number 4, we want to get a freshman within the first few tries. So in this case, you're going to use CDF. When you put it in with the CDF, you're going to start with the 0.2, then you're going to put in the 3. When you do this, you should get the exact same answer of 0.488. So our next example is kind of a different thing from the geometric probability, although a lot of people tend to confuse the two. So we're looking for the same situation as in the previous two examples, but we want to know what's the probability that if we choose 5 students at random, we get exactly 2 freshmen. So that means that the first 2 students you get can be freshmen. The first and the third student you get can be freshmen. The second and the third can be freshmen. The first and the 5th can be freshmen. There's many, many, many different possibilities there. Unfortunately, this does require a little bit more math. The good thing is that your calculator can do a lot of the math for you. So we'll do it by hand first, and then we'll use a calculator. But first I'm going to define what this actually is. So this is what we call binomial probability. So binomial probability is the probability of getting a certain number of successes in a fixed number of trials. And we have a formula for binomial probability. Unfortunately, the formula is a little bit unpleasant. So I'll go ahead and give you the formula that they write in the book, and then we'll talk about what it means. So our formula is probability that big X equals little x equals NCX times P to the X times Q to the N minus X. Looks pretty nasty, doesn't it? So let's break this one down. So the first thing is the probability that X equals X, just as the probability that whatever your number of trials is what you get. So in this case, or I'm sorry, the number of successes. So in this case, we're looking for 2. If you want, you can write off to the side that X equals 2. The N is going to be your total number of trials. In this case, our total number of trials is 5. Now, this NCX is going to have a formula that's a little bit unpleasant. I'll go over it in just one second. The P is, as in the previous one, it's your probability of success. Just like we had in the previous two examples, it's 20%. The Q is the probability of failure. Once again, it's the same as in the previous examples, it's 80%. So we have that. So now I'm going to go over what this NCX means. You may have seen this before. This is going to involve what we call factorials. So the formula for the NCX is you're going to do n factorial over x factorial times n minus x factorial. So I'm hoping that this looks a little bit familiar. If not, I'll quickly discuss what the factorial means. I'll just give an example. So for example, if you have 3 factorial, it's just going to be 3 times 2 times 1, which gives you 6. So you just multiply that number and every whole number below it all together. So let's work this formula out by hand. So we are looking for the probability that we get the number of successes, which is number of students that are freshmen, as 2. And I'm going to work this whole thing out. So we're going to start with the 5C2. We'll work that out on the side. Multiplied by 0.2 to the second power. The Q is our 0.8, and I actually wrote the wrong thing on the side there. That's going to be multiplied to the 5 minus 2 power, which is 3. So let's work out this 5C2 first. So that is going to be 5 factorial over 2 factorial times 5 minus 2 factorial. And I'm just going to multiply this whole thing out. You're going to do 5 times 4 times 3 times 2 times 1. On the bottom, we get 2 times 1. 5 minus 2 is just going to be 3. So we're going to do 3 factorial, which I got on the side there, actually. It's 3 times 2 times 1. From here, there's 2 options. You can either multiply everything out, or you can cancel things. So I'm going to go ahead and cancel things. It's easier. So the 3's, the 2's, and the 1's can cancel out. When you do that, you're left with 5 times 4, which is 20, over 2. So that gives you 10. So now this equation ends up being 10 times 0.2 to the second times 0.8 to the third. From there, you can just go ahead and multiply this out. And feel free to use your calculator on this. And when I did it, I ended up getting 0.2048, which is about 20%. As with the previous example with geometric probability, you can actually do this on your calculator. You'll find it is much, much, much easier. So go to the same menu as before, the distribution menu. This time you're going to go to Binomial PDF, and you are going to put in binomial PDF of 5, 20%, and 2. The 5 is our n, our number of trials. The 0.2 is our probability of success, our p. And the 2 is, it's the number that you want, the number of successes that you want, or they call it x. So that's what you're going to put in. When you do that, you'll find that you do end up getting the exact same answer as the previous thing. However, it's much, much easier. I do recommend that you know how to do it by hand, however, and that you can at least label what these values are, the n, the p, and the x. So make sure that you are okay with that. So next thing we're going to do has to do with finding the expected value and the standard deviation. And the formulas for these are in your book on page 394, if you want to look them up. So the expected value is actually not too horribly hard. It's going to be n times p. The standard deviation is n times p times q. So let's go ahead. This is example number 5, or example number 6, excuse me. Let's go ahead and find the expected value of this particular situation. So if you remember, our n was 5, our p was 0.2, and our q was 0.8. So let's go ahead and find the expected value for this. So our expected value, you're going to do n times p, which is 5 times 0.2. And that's actually going to be 1. So what that means is that if you take a sample of 5 students from Lorena, we are going to expect that there is 1 who is a freshman. So that's what that means. Our standard deviation, you're going to use the NPQ. So our n is 5, p is 0.2, our q is 0.8. When you work that out, you will end up getting 0.894. Our last type of example is probably our hardest one. And we're not going to do this by hand, we're just going to do it using a calculator. So for example number 7, we're still going to be using the same situation where we had a total of 5 students. The probability of getting a freshman was 0.2, probability of not getting a freshman was 0.8, and the number that we wanted in this case is actually going to be less than 3 freshmen. So that's what we're going to be looking for in this case. So we want either 0, 1, or 2 freshmen. That's our goal. Make sure that you read this carefully. A lot of people make mistakes on this. So the way that the calculator works is that it has what's called binomial CDF. Once again, you're going to go to the same distribution menu. It's under second vars, but this time we're going to do binomial CDF. And what CDF does is it lets you calculate the probability of getting a certain number or less. So we actually want to get 2 or less. That's what we're looking for. We're not going to do 3, we're going to actually do 2. The way that you're going to plug this in is you start with whatever your total is, your n, so that's going to be 5. You follow that by whatever your probability is, which in this case is still 0.2. The thing that you do next is the number of trials you want or less. So we want 2 or less. Make sure that you put in 2 and not 3. It's really important that you don't mess that one up. And actually when you do it, you'll find that the answer from the calculator is going to be 0.942, which is a very high probability. The last thing is getting 3 or more. And this one seems really hard, but actually all we're going to do is we're going to do 1 minus 2 or less. There's no real way to do something or more on the calculator. So I'm going to do 1 minus the probability of getting less than 3 or getting 2 or less. Luckily, we actually just calculated that out in the previous example. So we're going to do 1 minus 0.92. When you do that, you get 0.058. So Just to note that when I give this on a quiz, in general, I'm going to give one like the first part of number 7 and one like the second part of number 7, so that you just have to use the answer that you get from the first example.